So today we will be going over how to subdivide and triangulate a surface. We'll be doing this manually, so we'll be subdividing it piece by piece. There are tools out there that you can download and use as plugins for Grasshopper that will do this for you, just like paneling tools did for Rhino. But today we'll be going over how to do it manually, just so that you guys get a little better sense of how to use Cull Patterns, how to extract data from lists and list structures, tree structures, and hopefully get a little bit more proficient with how to use Grasshopper. So let's start a new document. So let's hide this guy. So I've gone in and drawn just a really simple NURBS curve. And so if you do that and then start to import, sorry, there might be some background noise. I got a couple dogs behind me. So import that curve, and then what we'll want to do for this exercise, you can use any surface, but for today, we'll mirror this curve and then create a biArc series of curves through it, just like we've done in the past. So let's mirror this. Mirror. Okay, and now right now it is defaulting to the YZ plane for the world plane. And so what we'll want to do is take that YZ plane and be able to manipulate it so it mirrors in this direction, and so we can have a little bit more control over that transformation. So if we type in YZ for YZ plane, and then want to, so it'll pop up here in the origin, and then we'll want to move it in the X direction. So unit X. And then we can plug in a number slider to adjust how far. Say there's good. And then we'll plug that plane into the mirror command so that now we have a nice two planes. All right. And I'm going to be hiding a lot of components as we go, because it's going to get really complex, and to be able to visualize the data really well, you want to have as many things turned off as possible so it doesn't muddle anything or overlap anything. Okay, and so now we'll divide these curves to create the base points for the biArc component. All right. And we'll want to plug in the same number slider for both, so that when we increase and decrease, they have the same divisions. And then we'll use the biArc command. So biArc, start point and end point. And remember, biArcs need a tangent, so we'll use a z-axis tangent. Since we want the arcs to be vertical. And then remember, our end tangent needs to be the negative of our start tangent. So if we just type in negative, not nag, negative, move this down, and then end tangent. All right, now we got our biArcs. All right. Excuse me. Okay. Hide this stuff. All right. And then, all right. So to create a triangulated surface on here, we'll need a series of control points along each one of the ribs. We'll use the ribs as the cross section, and then we'll have to divide the arcs to create those control points. So we'll use the joined biArc as our curve. And then we'll use a number slider for the count. And I'm going to turn this down just so we can visualize it a little bit better. Yeah, that should be fine. Okay. And so we need to be able, when you're using Grasshopper, to be able to be extremely prescriptive and intentional about what you're doing, because otherwise you're just going to go back and forth and not get the results that you are envisioning. So to think about this and how we want to approach it, a triangulated structure is going to need to go back and forth. And so if we look at this, these series of points, we'll want to take this first point and connect it with the second point in this row, and then back to the third point in this row, fourth one here, fifth one there, so on and so forth. And so to do that, we'll have to choose every other one in each row. So we'll have to start and then skip this guy, use this point, skip this point, and then in this next one we'll have to skip the first point, start with this guy, skip this second point here. And so we'll need to be able to extract every other row, and then we'll have to extract every other point on those rows. And so to do that, we can use a cull pattern. So a cull pattern, I think I've gone over it before, but a cull pattern uses a true-false Boolean pattern. It's just a series of either true-false statements. And if it's true, it'll keep that number in the pattern. If it's false, it will remove it. And to start off, we need to remove extract every other row or curve in this point, or in this situation. And so to do that, we can't just do a cull pattern and just plug in those points because it's going to do it to every single row. If we look at a panel right now and look at the actual data that's coming out of those the divide curve, it's broken up into those data structure, those tree branches. So 0, 0, 0 is the first branch, 0, 0, 1 is the second, and in each one of those branches are the 10 points, 11 points that is the curve has been subdivided into. And so what we need to do is extract the 0, 0, 0 and then the 0, 0, 2 branch, so on and so forth. And to do that, we can use the parameter viewer, or param viewer. What that will do is it will show us all the branches. So there's 20 branches and all of the names associated with that branch, and then the number of items within each of those branches. And so we'll want to use the cull pattern on this parameter viewer to be able to extract every other branch, and then we'll assign that to another component called tree branch, which will then extract and identify all the remaining branches in the structure. So we have a cull pattern here, but it's not in the right cull pattern. Right now it's in false, false, true, true. We want it to be true, false to get every other row or branch in the script. So if we go to set multiple booleans, here we can edit that true, false pattern. And so we'll type in true and then enter false. It's organized in this vertical structure, so you need to whatever pattern you come up with, you need to make sure that you press enter and have it stacked like this, and it repeats, so you don't have to write out true false 20 different times. You just do it once and it will repeat itself over and over. Okay, so once we're done with that, commit changes at the bottom. All right, and now it is calling out, and then you got to plug in the parameter viewer into the cull pattern, and then we'll have to take tree branch, and it's going to receive, so this component right now, if we look at a panel right now, what this component is doing, the cull pattern, it is just calling out the names of the branches that are here, right? So 0, 0, 0, 0, 0, 2, 4, 6, okay? What we need to do is take the original list from the points. We need to take the the path, which is 0, 0, 0, or the names of the branches, and extract those individual branches. So now we have the extracted branches along with the data associated with it. So 0, 0, 0, 0, 0, 2, so on and so forth. All right, so now if we click that, now we have all of the individual or every other row selected. And what we'll need to do, I'm going to make this smaller. What we'll need to do is do that for the other sections. So we have like 1, 3, 5, 7, and so on. Right now we need 2, 4, 6, 8, and so on. And so what we can do is just copy. Actually, what I'll do is I'm going to group this because we'll be using this a lot. I don't think I've showed you this before. If you highlight the components that you want to group and then you hit control space, it'll pop up. This is typically where we'll unpreview or preview stuff, but you can also group things. It's this little fidget spinner looking component, and if you click that, then it will be grouped. You can still edit the data within it, but it will be grouped, and you can also put a title on here. So if you right click on the group color outline here, you can, up here at the top, you can label a group, and we'll call this branch cull pattern. Okay. All right, so we'll copy and paste this group. Oops. Just kidding. Why can't I? There we go. Highlight everything, copy and paste it. Okay. And now, instead of having a true false pattern, we'll want to invert that and have it be false true pattern. All right, so now it is extracting the 2, 4, 6, the even numbers in the branch. Odd numbers, even numbers. All right, we'll go back here and start hiding. So turn the preview off. So I'll keep the biArcs on just because it's a little bit easier to visualize. Okay, so now we have these two branches of points identified and separated. Now what we need to do, so if we go back, we'll want to start with this point, connect with this guy, and then go to 3, then 4, 5, 6. Okay, and to do that, we need to remove the even numbers, or every other point on this list and every other point on this list. And so we'll need to do somewhat of the same thing, but instead of having to go through the branch cull pattern, all we need to do is just do the straightforward single cull pattern. So go into this branch and then go to set multiple booleans, true, false, commit changes. Okay, so now we have every other, and I actually copy and paste that guy, plug it up for this branch. So I want to start with this point and move to this point, and so for this cull pattern, I'm gonna switch it to the false true pattern. And I think I've kind of been hinting at it, but this structure right now starts at the bottom left corner, this point, and moves from left to right and from bottom out. So the rows start down here and move up. The points start on the left and go to the right, just to make it a little bit simpler, or a little clearer. And all right, so now I have every other point on this structure, starting with this one with this cull pattern, and every other point in this row starting with the second point moving forward. All right, and so let's unpreview these guys. So now we have, and these are just arrows, they're not points, just to be clear. All right, so now we'll want to connect those. All right, so we can just select a simple 2-point line, start and end point. All right, and now we have this guy. So what it does is starting with this point, associating with the first point in this line, same thing, second to second, third to third, fourth to fourth, and so on. And so to be able to get this line going across from this point to this point, we'll need to remove the first point in this list so that it starts with this point and connects with this point. And how we'll do that is starting with this this data structure, these arrays of points. We want to remove that guy. So this is the first point in the list. And so instead of using a cull pattern, we'll use what's called a cull index. I think I've gone over it before, but I'll review it just in case. Cull index is removing a certain item in the list. So every item in the list has a number associated with it. 0, 1, 2, 3, 4, 5 associated with the data. And what cull index does is you specify what number in the list you want to be removed. So let's say 2. It will remove this piece of data, this point in the list. And it will do it along every branch. So every one of these number 2s, it will remove. So if we bring in that list, and we want the first item in each branch to be removed, first item in every list is 0. Remember, not 1, but 0. And so we can either type in 0 or we can use a panel. Remember, a panel is can not only be used for to visualize the output of components, but also you can use it to type in. Make sure you don't have any spaces or anything extra, so don't have a enter, because that will make it not compute. Plug that in, and now we have a list with the first item removed in every list or every branch. All right, so now take this guy and plug it in. Now we get every other. And one thing we got to be careful of when we're creating these lines and subsequently the surfaces that we'll create is that we want to make sure that there are no recurrent curves in the script. And what I mean by that is, see how in this array of curves you get this extra one down here, and when we select the other line it's still highlighted. That will be what we call a recurrent piece of data. It is a duplicate essentially, and we want to be able to remove those duplicates so we don't get multiple surfaces or different lengths of lists when we get down the line. You don't want overlapping stuff. We want it to be as clean as possible. So in this specific script, we'll want to remove the last item in this list of lines. And so we'll do the same thing we did up here where we're removing the first item, but instead of removing the first item, and I'm copy and pasting the cull index with the 0 called out, we'll want to remove the last item. And the last item we can select by hitting -1. -1 starts from the beginning of the list and goes back 1, which is going back to the last item of the list. So it's an easy way, instead of trying to figure out all the length of the list and then subtracting 1 to get the list length, like the itemized number of the last item of the list. All you gotta do is hit -1 and it'll remove that last item, this guy right here. So now we have two really nice lists of lines that go along every other row. Now, problem is, of course, we do not have these rows right here connecting, and the reason that is because it starts with this point, connects with this point, and then starts over in this next list, starts with this point, connects with that point. And so just like we did we've been doing, we need to remove this first row from the list of branches so that the 2-point list, the start end point, starts with this row of points and ends with this row of points. So we'll do the opposite, or the alternate row of triangulated points. So to get rid of this first row, we need to use that branch cull pattern. So we'll copy and paste this group over here. And now what we'll do is we will take, we need to find this first row, which is this guy. All right, so let's move this up so it's closer. So we want to remove this first row of green points. So we'll plug this list in to the list and this into the tree. Remember, you gotta plug in the original point list. We have to plug in the original list into both the tree branch and the parameter viewer. And instead of using a cull pattern, we need to go in and use cull index, because we just want to remove the first item of the list. And we can go down and copy this panel of 0, because 0 is the first item of the list. And plug this into the path. And now if we preview this guy, now we've removed this row of points and started with this. And so now, oh, and if you add a component to a group structure, you need to highlight, click the components that you want to add and then the group, and right click on the group, select add to group, and now it's part of that group. Okay. All right, so let's go back. So now we have a removed item, or a removed row. So we want to start with this row of points and connect with this new called out pattern of this row of points. So we can copy and paste 2-point line, plug in this branch, these guys, and this one is already selected. So now we have the one set of rows, and as you can see, there is that recurrent curve, recurrent line ending here. So we'll want to take this cull index with the -1 already associated with it and just plug that in here. So now we got unpreview. Now we don't have that recurrent line at the end. And then take the, and then now what we need to do, so it starts with this point, this goes to this point, starts with this point, goes to this point. Now we'll want to remove this point down here in this list, which is up here. We'll want to remove that first point in the row so that it starts with this point and connects with this point. So these 2 points are the first points in the list. And so what we can do the same thing we did. Take a cull index we already have that removes the first component or first item in the list, which is 0. Copy and paste that, plug it in after this guy, just plug that in. Now we have a list that removes that first point down here. And so we'll just plug this guy in, unpreview. Remember, if this guy is grayed out, it means you are not previewing it, so don't freak out if you can't see it the first time. All right, and so now we have a fully triangulated structure along the entire surface. All right, make sure there's no. Okay, so I don't think we had this before. So as well as having recurrent lines down here, we also have recurrent lines down here. And what we need to do is remove this branch of recurring lines by using a cull branch cull pattern, which is actually before I copy and paste that, I need to change this, because this is not a branch cull pattern anymore. This is actually a branch cull index, because we're just removing a certain item in the branch structure. So copy and paste that back here. Now in both of these lists we have a recurrent row, so we'll want to do this to both lines. So plug this guy in to both tree and parameter viewer, copy and paste this down, do that same thing with this list. And then we'll want to change this. We don't want to remove the first branch in the row, we want to remove the last branch. So we'll change this to -1. And I'm just double clicking on the panel, and it brings up this properties panel. This will come up once you've first input data into the panel, then that properties panel will come up. So now we have, instead of having this recurrent row of lines back here, now we have a nice cleaned up branch. And let me go back, let me turn off, unpreview these guys. Need those. All right, I'm gonna take, so these are the first two sets of curves. I'm gonna take them and drag them back here. So now we have all 4 sets of curves aligned. And now I want to create surfaces. And before I create surfaces, the panelized triangulated structure, I want to go back and I'm going to turn some things off and turn some things down. So first thing I'm going to do is turn the biArcs off, because when we start creating these triangulated surfaces, it's not going to be rounded anymore. It's going to be faceted. So we'll turn these off, and we will also go back and I'm going to turn down the number of panels just for now, so it's easy to work with. Remember, if you have a lot of panels or a lot of a large number of data that the script has to go through and compute, it's going to take a really long time to solve and potentially slow down your working process. And so if you know that you're still working on the script and you need to be quick, just make sure that you reduce the number of items within the script so that it doesn't have to compute so much. So I'll turn this down to 10. This is the amount of divided curves along our initial curves that we drew in Rhino and mirrored. And then I'll go over and turn the divide curve down, which is the cross sections. Now, I don't know if it should do it. Might not. Huh. I guess we set it up pretty well. Just remember that sometimes, and for some reason it's not happening in this script. The last time I did this, it was happening. So I'll just review it. Sometimes when you use cull patterns, you'll want to make sure that the information that you're culling is either an even number or an odd number. And so you'll need to make sure that your divisions or whatever you're using to cull is either an even or an odd. And remember, if you right click on the number slider here, you can specify those as either even or odd. For some reason, I don't know if I set it up a little bit differently than I had in previous, but it's not doing what it was doing before. So don't have to worry. All right, so let's just turn this down. Get back to what we were doing before. Okay. Oh, all right, so now to create surfaces, there's multiple different surface creation components here. What we're going to use is a edge surface. So you can either go from the surface tab up here, or you can type in edge surface. And it's going to ask you for up to 4 curves. You only need 2 to create a surface from, but you can use 4 if you want. And we will start to plug this guy in. So we'll plug the first one here. And we want to make sure that we plug the curves that are next to each other in the rows. So this guy and this guy in. And then we can do that for this guy and this guy. Okay. And now what we need to do, so it's gone through and taken that those first array of curves in the order that they're in right now. What we need to do, and it's creating recurrent surfaces back here, so we'll want to remove those first. So go back to one of our Cull patterns that removes the last item of the list, one with the -1. Plug those in, copy and paste that down, make sure to preview it again. Alright, now we've removed those. Okay, and then to be able to get this guy, the panel in between, instead of starting with this curve and lofting it to this curve, we want to start with this curve and loft it to this curve. Just like we've been doing with the points, we'll want to do with the lines as well. So we'll have to call out the first line in this array, which we can do by using our cull item, or excuse me, cull index with the 0 as the indice, or the index. I'm going to pull this over a little bit so it's a little more open. Alright, and now we got to find the array of curves that start with this curve, which is that guy right there. So we'll plug in this list index, plug that list into this list index. If we preview it, it has, yes, remove that curve. And then we'll want to just loft or use it with a edge surface with this guy. So copy and paste this down. Make sure to preview it because we turned those off originally. And then instead of using this initial array of lines, we can use this one. So just replace it. Now we have triangulated panel that is starting here. This might be, let me go back. Ha! I knew we need to make this even. Alright, so if we don't have this even, if we have it, this is what starts to happen. You start to get really weird recurrent information within your script. And so remember, whatever information you are using a cull pattern with, make sure it's either even or odd. And that'll depend on your cull pattern, right? So our cull pattern right now is true false. So it's an even number of an even numbered Boolean list, true false, 1, 2. So we'll want to make these even. So go in, edit, make it even. Boom, we're good. Now when we scroll back and forth, don't get any of that recurrent information. Okay, and now we need to do that same thing, calling out the first item in this array of lines. So we'll want to remove this line down here. So find that structure or that array, which is this component here, copy and paste down the cull index with the 0 indexed and plug it in. Now we have that array with the first line removed. We'll copy and paste this component down. Make sure that, okay, we have this array highlighted. It's already input into curve A. Take the new culled pattern, plug it into B. and make sure, of course, it is visible. Now we have a fully triangulated, panelized surface. All right, and right now they're in their individual lists. You can take multiple lists and put them together as one by using the merge component. Merge takes all of the different data lists and plugs them in. So if you plug in multiple lists, once you get to the max number of inputs, it'll add one. So if I plug this in right now, it's going to add a fourth, plug it in, fifth. You can go down if you know and either subtract or add with these little toggles. These little toggles only show up if you zoom in. All right, and now we have, and if we unpreview these, now we have one full list of the panels. All right. And now what we can do is we can use those triangulated panels just like we've been doing with our in previous classes with the Attractor scripts or transformations. So I think in what I showed you before, I was using a point attractor. So this time we'll use a curve attractor. So if we go back to Rhino and we just draw a curve in the middle of this guy, like so. Pretty simple, but what we can do, let's import that curve into the Grasshopper environment. Set one curve. Now it's in there. All right, and just like in past classes, we'll need to extract this center or centroid of the panels. So go into geometry and use the centroid component as our center points for each panel. And then to get an attractor script, remember we need to find the distance between points on this curve and the points of the centroids on each panel. And so we'll have to divide the curve, and then I am going to take the list length, find the list length of this. And we'll want to flatten these results. These are still in the 4 branches. When you plug in each list into the merge component, it maintains the branch, the tree structure of that. So if we go into panel and visualize what's in here, right? We have all of those lists. So we need to flatten this result. Okay. And then take the list length of either the panels or the centroids, plug that into the count. Now we have a curve that's divided same number of points as the panels, and then use closest point, not points, but point, and take the centroid and the points, and then all right, well, now we have the closest points and their distances. Let's use scale as our transformation that we want to make an attractor, or use the attractor for. So we'll want to take the panels, plug that into the geometry, take the centroid and use that as the center of the scaling. And then we need a factor. At factor, we can either have between 0 and 1, or actually you don't want to use 0. We'll cover that again. So we'll need to remap the distances to those factors. And so using remap, we'll use distance, type that into value, or plug that into value, excuse me, and then we'll need the source domain. So remember, to get the domain of a certain list, we'll use bounds. Bounds. Yep. Now we have our source domain, plug that in. And then we need a target domain. So a target domain, we can have anywhere from, we can have it from 0 to 1. Excuse me. But remember that scale doesn't like 0, because if we have a 0 factor for a 0 scale factor, then it nullifies that panel and it removes it from the list, and it'll plug in red. So we'll want to change that domain from 0 to 1 to let's do 0.2. So 0.2 to 1, commit changes. Remember, you got to hit commit changes. If you just click out, it will not register the change that you just made. And then take those remapped components, put that in. And if we turn off the original panels, now we have really nice Attractor script with the panels. We can increase the amount by using the toggles that we created earlier. Oops, wrong number slider. All right. Now I have that. Now we do not have the intermediate members because we never created lines for that. So what we can do is find those arrays of points, which should be, so those are the surfaces, these are the lines, so we need to go back to the points. Of course, we've turned off. Here we go. So there's one, there's the other. So all we need to do here is use a polyline. Plug that into the vertice. Copy and paste. Find the other array of points. Plug that in. Now we have a structure. All right. So your assignment will be to just follow along, recreate this, send me a high-res image of your script, and a lot of you haven't been sending me that. So remember, it's File, Export High-Res Image. You can select the file location up here, hit Save, sure. All right, and then just press OK. It'll come up with this dialog window for a second, and then once it's done running, it'll go away. Now you have a really high-res PNG of your script. So submit that, as well as an image of your, let's just have the curves, the individual line structure and the panel structure. So you can turn off and of course I've turned off some of the curves. So just have this guy. You can turn off this as well. All right. Should be pretty straightforward. If you have any questions, just let me know. Feel free to email me. And this will be due at the regular time next week. So October 15th. All right. Thanks, guys.